Alright, in this video we're going to be putting it all together, the slope, y-intercept, and writing an equation. Okay, the slope-intercept formula, the slope-intercept equation, is what you see there, y equals mx plus b. This is a really famous equation. It's just because it relates our two variables, our x and our y, to the slope and the y-intercept. All of this translates directly into a slope, a y-intercept, and the graph or table that we can match up with it. So first off, let's just make sure we're clear on what everything is here. The m is our slope, the b is our y-intercept. So if I ask for the slope of this equation, this first one, y equals mx plus b, the m, or the slope, is 4. The b, or the y-intercept, it's really important that you understand that that's a -9 or a -9. Those are actually the same thing here. It's a -9 as our y-intercept. That sign is attached to the number. It's not just positive. And the second one, the m, the number that's in front of the x, is a -2. That's our slope. The y-intercept here, since we're adding, that is a positive. It's just a positive sense. Number 3 here, y equals 1/2 x plus 8. The m, again, is just the number that's sitting in front of that x. That's 1/2. And the b is 8. If you wanted to write that as 0.5, that's fine too. Usually you see slopes as a fraction. On that fourth one, the number in front of the x is -3/4. You can see that that negative sign's out in front. I'm almost always going to put it with the top, just so I can clearly see that the rise over the run is showing that it's decreasing by 3. It's going down 3 and over 4. And again, when we see that we're minusing a number here, that's telling us that our b, or y-intercept, is a negative number. Here it's -12. Now I'm going backwards. I'm given the slope, I'm given the y-intercept, and I want to write an equation. Y equals mx plus b, mx, there would be 4x, plus b, since I see that it's a -3 or a -3, I'm going to write it as a -3. You could write plus a -3 if you feel more comfortable with that. I'd rather just have one sign in there though, so I'm just going to write -3. And for the last one, y equals mx plus b is y equals 1/2 x, that's the slope, and it's a +7, so I write +7. So the parts of the equation come from the slope and the y-intercept. Now we're going to have to go straight from a graph to that equation. So we're going to look at these graphs. We're going to find the slope and the y-intercept, and then use those to write the equation. Identify the slope and y-intercept from this graph, and then we're going to use those and write the equation. I like finding the y-intercept first just because that's a lot easier. You don't have to count anything, you just look at the point. That point is where our graph hits the y-axis, so our y-intercept is 0, -1. And when I count out the slope, I'm usually going to use that as a starting point. I'm going to find another point that's on these grid lines. Anything else that's on these grid lines so I can count to it easily. I see that this point is also on the grid lines. I could count backwards also if I wanted to count from, that looks like I could also use this one. I could probably also use that one. All of these points would work. I'm just going to use these two just because I see that they're clearly on the grid lines. I'm going to count my rise and run now. Rise over run here is 1, 2, 3 down. That's a -3. My rise is -3, and my run is a +2. So -3/2 is my slope. If you wanted to change that to -1.5 again, that's fine. Just usually you're going to see slope as a fraction. So my equation is y equals mx plus b, y equals -3/2 times x. And my y-intercept, it's really just that number. It's just wherever it hits the y-axis, and it's just the y-coordinate there. So here that's -1, or in my equation, it's going to show up as a -1. That's the equation for that line. It's really easy to test this. You should know from the last few years how to set up a table for this. If you plug in 0, we should get -1. If you plug in 2, you should get -4. You can test this equation. You can plug these in to that and see if you get the right numbers. These are two different ways you can figure out if your equation's right, using the slope and the y-intercept, or using the table. All right, on this next one, again, I'm going to find that y-intercept first. I got my y-intercept right there. That is 1, 2, 3 up, so that's 0, 3. And I'm going to use that as a starting point. I'm going to count up to the next point that's on a line. So I can see it looks like it might hit there. I'd be a little bit cautious about that, though, because that looks like it's almost off the graph. I might use the one that's behind that. I see that this point is also on those grid lines and easy to count to. So I'm not actually going to use these two. I'm going to use this point and that point to count out my rise and run. It's going up 1, 2, 3, 4, 5. My rise is 5. And my run is 1, 2, 3. So my slope is 5 over 3. And it's going uphill, that's why it's a positive number. It's 5 over 3. And to write the equation, we really just plug those into the equation where they're supposed to go. Y equals mx plus, I see that it's positive 3, so I'm going to write plus 3. The equation doesn't always look like that. It could also be flipped around. So I could write this differently if I wanted to. Y equals mx plus b is the same exact thing as y equals b plus mx. So there are times when you're going to see this flipped around. So we could see this as 3 plus 5/3 times x. Those are the same thing. If you're more comfortable writing it the first way, I would probably stick with that just because that's usually how we see it. Y equals mx plus b is pretty much the standard form of that. We're going to do these two more examples with you. Trying to find the equation of this graph. Again, we're trying to find the slope and the y-intercept just so we can write the equation. Y equals something times x, and then plus or minus a b value. So I'm going to find that b first. That's the easiest part. Just find where it hits the y-axis. That is -3. So I can start with that part right away. It's going to be something times x minus 3. And then I'm going to count out to the next point. Actually, you can see that all of these points hit those grid lines. So it doesn't matter which two you use. I'm going to use the y-intercept. I'm almost always going to start with the y-intercept if I can. And then I'm going to count to this very next point. My rise is -1. It's just going down 1. And my run is a positive 1. My rise over run is -1 or a positive 1. Or if we just did that division, that's just -1. And I can write that right into my equation. Y equals -1 times x minus 3. Always check to make sure your equation actually makes sense. This is a negative slope with a y-intercept that's below the y-axis. Sorry, the x-axis. It's below the x-axis, so both numbers should be negative. The slope is negative. That's that number. And the y-intercept is below the x-axis, so that should also be negative. Okay. Actually, I'm going to have you do these last 4 on your own. I think you can handle that right now. If you need any help, you should definitely be asking. But I think you can make those equations on your own right now. They're asking us, again, just like we did in these previous 3 examples, find the slope and the y-intercept from the graph, and then write the equation. These last 3, you're just writing the equation as y equals mx plus b, and just plugging those numbers in where they're supposed to go. On these next 4, we're given the equation, and we're trying to write And we're trying to graph those on these graphs. So you should know already how to do this. If you get stuck, if you forget what slope and y-intercept really mean, you can always use a table and just plug in some numbers and see what kind of points we get for those. But we'll find that slope and y-intercept are way easier to use. You don't have to actually plug in anything. Always start with the y-intercept. Wherever the y-intercept is, that tells us where our graph starts, where it hits this y-axis. So I see that my b equals 4. That's the first point on this graph. 0, 4 is where this graph starts. And then I see I have a negative 1/2 as my slope. That means my rise over run is negative 1/2. That's telling you instructions on where to go next. It's saying go down 1 and over 2. Down 1 over 2. That's the next point. I'm going to erase that part in the middle. But it's telling us that is where the next point is. You're going down 1 and over 2 to get to the next point. And you can keep doing that as far as you can. Keep going down 1 over 2, down 1 over 2. Keep doing that as far as you can go. That tells us where the next point is. Make sure you get a straight line with this, otherwise you're doing something wrong. You can also go backwards on this. If you imagine that you went down 1 over 2 to get to this point, you had to go back 2 and up 1. Back to up 1, back to up 1, back to up 1. That gives us our straight line. And actually, we want to put arrows on the end of this to show that that goes on forever in both directions. Start with your y-intercept, and then just count out your rise and run. It's the exact same thing we're going to do on this next one. Before I get into that, actually, I want to talk about what that slope means. That slope equals 3. A slope of 3 is really saying that I have a rise and run of 3 over 1. Those are the same thing. 3 over 1 is really just the same thing as 3. I'm just writing that like that so I can see that my rise and run both have numbers attached to them. My rise is 3, so I'm going up 3 and running 1. I'm still not going to start out with that point. I'm going to start out with my y-intercept that starts at positive 2. So I'm starting at 2, and I'm rising 3 and running over just one spot. Rising 3 and running over one spot. Remember, you just have to plot 3 points on these to confirm that you actually have a straight line. 2 points doesn't do it. You have to plot at least 3. So if those 3 points are all you need, then you're good. Sometimes you will have to count backwards. So we'll need to know that we have to go back 1 and down 3 to get to the previous point. Back 1, down 3, back 1, down 3. That gives us the 3 points that we need. Kind of missed a little bit. We also want to make sure that we have 2 arrows. It goes on forever in both directions. All right, on number 8, we don't have a number in front of our x. There is no number there. There's really a 1 in front of it. So we actually have the number 1 in front of that. It's just to signify that we have 1x. We don't actually need to write that, but you need to know that if there is no number in front of the x, it's actually a 1x. So that's telling me my rise over run is equal to 1. So we can think of that as 1 over 1. You can think of that as 2 over 2, 3 over 3. You can count out any of those rises and runs. It actually doesn't matter. I'm going to use 1 over 1 just because that's the simplest. I'm just counting 1. But you can use all of those. Those all simplify to 1. I'm going to start at my y-intercept. I'm going to start at 4. 1, 2, 3, 4. And count a rise and run of 1 and 1. Up 1, over 1. And I'm going to go backwards. I'm going to go back 1 and down 1. And that gives me my straight line. The next one I'm actually going to show you a way to rearrange this if you want to. You don't have to write it like this, but I think it's a little bit clearer. We can write this as y equals negative x plus 5. Those are the exact same thing. This is something that you really need to get comfortable with. A negative x and a minus x are the exact same thing. The sign in front of the number is attached to that number. The sign directly in front of the x is attached to that number. The 5 is not being subtracted. This is a positive 5. So we write that as a plus 5. That tells us where to start our graph. We're going to start 1, 2, 3, 4, 5 up from the y-axis, from the x-axis. Our y-intercept is a positive 5. And our slope is negative 1, which is the same thing as negative 1 over 1. So I'm going to go down 1 and over 1. And you can go with that as far as you possibly can. Down 1 over 1 each time, or I can count backwards. Back 1, to the left 1, and then up 1. It's the exact same thing going forwards and backwards. And you can see the negative slope matches up with our negative slope in our equation, and the positive y-intercept, the positive b, matches up with the positive b in our equation.